Hi everybody, welcome to your last lecture in Module 1, Lecture 1.3, the original Industrial Revolution. So today we are talking about the first Industrial Revolution, which I like to think is the development of tool making among our hominin ancestors. Toolmaking has been linked to many radical evolutionary changes within humans. Things like changes in diet, increasing brain size, the development of language, and changing social organization. Okay, so in order to understand how tools may have altered human evolution, let's talk about what's going on in Africa during this critical moment of evolutionary change. So the first kind of thing that we have here is a changing environment during this transitional period around 2.5 million years ago with the Pleistocene. During the Pleistocene, we also see kind of greater mountain chains begin to form, like the Alps and Himalayas, as well as large land masses moving around, and animals like horses, elephants, cattle, and camels begin to appear. The environment during this time also begins to shift. As we kind of talked about in the last lecture, things have become much cooler than they were before, and these kind of swings between warm and cool temperatures become much more frequent than they had been in the past. We also have an expansion and diversification of the number of early hominin species moving around and inhabiting the African savannas. So between about 2.5 and 1.5 million years ago, there's kind of two primary hominin lines living in East Africa. One, the Australopithecus line, associated with archaeological remains like Lucy, which we talked about in the last lecture, and then the Homo genus. So the Homo genus represents the early ancestors of us, modern anatomical humans. So there's actually three different forms of early Homo sapiens or Homo genus living around and moving around during the time of this industrial revolution linked to tool making. One is Homo habilis, Homo rudolfensis, and Homo ergaster. And it's Homo ergaster who is the kind of progenitor of us modern humans. So the genus Homo, and more specifically Homo habilis, was the kind of central protagonist in the development of stone tools. Homo habilis had a smaller jaw and teeth, which is suggestive of greater food processing capabilities than other types of hominin species living at this time. This Homo habilis also had kind of longer arms, suggesting that they spent a decent amount of time in trees rather than being fully kind of bipedal and living on the ground. We also see that there's a kind of increase in body size with Homo habilis compared to other hominin species. A critical component of Homo habilis anatomy is that they had more dexterous hands with larger opposable thumbs, which allowed for powerful gripping and precise manipulation of fine objects. Finally, compared to Australopithecus, Homo habilis had a larger brain with a well-developed Broca's area, suggestive of advanced control of face and mouth muscles needed for linguistic communication. In 1960, Louis Leakey reported the first skeletal evidence of Homo habilis during excavations in the Olduvai Gorge in Tanzania. Although no tools were directly associated with the habilis remains Leakey found, the body's anatomy, along with the discovery of crudely chipped stone tools in the lake bed within the Olduvai Gorge, suggested that habilis had tool-making abilities. Richard Leakey later found the famous Skull 1470 in eastern Turkana, confirming that the existence of Homo habilis in no uncertain terms. The earliest artifactual evidence for stone tool making comes from the Gona site, located in the Awash Valley in Ethiopia. This site, the Gona site, was discovered in 1992 by Seleshi Inma and John Harris. What they unearthed were hominin remains with some 2,000 or more small tools and what's called lithic debris, the debris that's left over from making stone tools. These early tool remains dated to roughly 2.6 million years ago. The discovery of the Gona site pushed back the date for stone tool making by about 150,000 years. Most of the tools found at the Gona site and other places in Ethiopia were broken cobbles and flakes. These tools are referred to as Oldowan technology and were defined by Mary Leakey. As more sites have been discovered, the Oldowan technology appears as a kind of simple but highly effective technology that grew more complex over time with the appearance of crude, what's called bifacial working, in which cores, the kind of central rock that a tool was produced from, were being flaked from both sides. Okay. So why were these crude, simplistic tools so important for the origin story of modern humanity? Well, first of all, tools provide insights into the development of human cognition. Skilled tool manipulation is an asymmetric bimanual activity. In other words, individuals divide the work that we do between both of our hands. Specifically, one hand tends to be used to execute the action, while the other hand stabilizes the object. Hand preference, typically right-handed for most of us, distinguishes humans from other living primates. Archaeological evidence from stone tool sites throughout Africa indicate that handedness, or the preference for one hand over the other, is reflected in the reduction strategy used to produce flakes. For example, at the Kobe site in Kenya, over 50% of the flakes found at that site were produced using a right-hand orientation, meaning that the person making that stone tool was using their right hand to do so. The distribution of the scatter of stone flakes produced in this, what we call napping process, all lean towards the dominant hand. So all the flakes were scattered towards the right side of the site. So this kind of human right hand bias is related to the cerebral dominance of the left hemisphere of the brain, which is also linked, that left hemisphere of the brain is also linked to language. So scholars basically suggest that the specialization required to produce tools using our right hand was linked to the development of the left side of the brain, which eventually became responsible for speech production and comprehension. Although we can't necessarily infer language from simple artifacts, there are two lines of evidence that indicate that Homo habilis may have developed language at this very early date. So think 2.5 million years ago. So the first evidence comes from that skull that I mentioned before that Richard Leakey found, skull 1470, which was found in the Olduvai Gorge, and showed that the brain size of this particular Homo habilis species was about 300 cc's, larger than other types of skeletal evidence that had been found, and that the frontal lobe was more human-like, especially in that Broca area where speech control is located. Scholars also found that mammals, except for adult humans, have a larynx high in the neck, which allows the larynx to lock into the airspace at the back of the nasal cavity. This allows other mammals like cats and monkeys to breathe and swallow at the same time, but puts limits on the sounds that they can produce. The position of the human larynx, low in the neck, actually allows the vocal cords to modify sounds, which is the key to human speech. Another reason why early evidence of tool use is so important is because these tools provide insight into changing hominin subsistence practices. So basically, the theory goes that the larger brain size of the genus Homo required more energy. This kind of stable basal metabolic rate of Homo habilis was maintained by a reduction in the size of the gut, corresponding with this increase in the size of the brain. This reduction in gut size could only be possible as a result of a higher protein-rich diet, because a higher fiber diet requires more intestinal action, but under a smaller size. So cut marks on bones found throughout Africa confirm a kind of growing importance of tools in processing meat in order to sustain the metabolism of Homo habilis, who had a smaller gut but a bigger brain. Some of these tools with cut marks have been found in Ethiopia and in Tanzania, in areas with no appropriate flint knapping materials, suggesting that hominins traveled to these sites with their tools actually in hand. For example, in the Middle Awash Valley in Ethiopia, archaeologists have found evidence of skinning, cutting joints, and breaking open bones, but no actual evidence of tool production. Sorry, that's my dog. Similarly, in the Olduvai Gorge in Tanzania, archaeologists uncovered an elephant bone processing site, which included 172 stone tools and evidence of butchering of bison not far away. So, why was eating meat so important for our social and biological development? Well, increased meat consumption is directly linked to that larger brain size that I was just talking about. That larger brain allowed for greater intelligence as well as larger social groups. Scholars have argued that while Australopithecines lived in groups of around about 60, Homo habilis lived in much larger groups, somewhere between 80 and 100 individuals. In order to coordinate all these people, there must have been a development of both linguistic skills as well as greater intelligence to coordinate across larger group members. These larger social groups participated in coordinated hunts using combined knowledge of the landscape. These coordinated hunts have long been viewed as the selective context out of which human cognition and social collaboration evolved. Another kind of key reason to think about the role of meat in human cognition and hunting and tool making is the relationship between meat and material culture. So shifts in brain capacity and tool making led to enhanced communication, information exchange, and economic and social insights. In this emerging social system, meat became a valued good that was the predecessor to later currency-based human social systems like we have today. So you can think about back in the day, meat being the same as money. The value of meat as a currency is linked to a couple of different factors. So first, it's rare. It's very difficult and dangerous to obtain. It also has a high nutritional content. It's a compact source of fat and protein, and therefore very desirable. It's also shareable. It can be broken up and distributed to these larger groups that we know are associated with Homo habilis. It's also highly perishable, so there's actually no advantage to hoarding meat or trying to store it for long periods of time. It's also meaningful. It's an index, it's an indicator of how good a given hunter is at physical and mental labors. And finally, meat is gendered, insofar as it's usually males who are doing the hunting. So as part of a kind of newly evolving social system, it's possible that meat may have been used as a trade good in negotiations between hominins. For example, both chimps and humans distribute meat to allies and withhold it from rivals. So meat may have also been used as a way to negotiate and to solidify social bonds in these larger groups. So in the last portion of today's class, I want to talk a little bit about another major theorist of the evolution of kind of early human capacities. Specifically, I want to talk about Friedrich Engels. So unlike Darwin, who argued that the brain was what drove human evolution, Engels argued that it was the hand that drove human evolution. So what did Engels say? Basically, according to Engels, walking on 2 feet, bipedalism, freed up our other 2 appendages to do work, things like tool making and provisioning young, as we talked about in Module 1.2. Next, the hand was used to produce tools, the Industrial Revolution, like we've been talking about today. The use of tools made all the rest of these kind of labors linked to subsistence so much easier. Things like hunting, cutting, fighting, all of this became less time intensive and much more efficient with the development of stone tools. The transition from a primarily plant and fruit-based diet to a high-fat, energy-rich meat diet had all sorts of evolutionary consequences, particularly positive consequences for the brain, right? This high-protein diet fueled the development of a more complex and larger brain in our early Homo habilis ancestors. That increase in brain size was likely linked to the development of language, which provided the basis for human sociality. This kind of new development of human sociality and language and cooperation in larger groups helped Homo habilis and other hominin ancestors develop fire. They also developed around this time what's called a predatory economy, which involved the domestication of plants and animals. So we see this kind of transformation from a hunting and gathering lifestyle into a highly productive economy in which humans were controlling their own food sources through agriculture and pastoralism. So basically, Engels said that once humans had developed fire, tools, and domestication, life was pretty good. The hand was enlisting the labor of tools, which further increased production and efficiency, which produced the basis for human society, helped develop language, helped build up the brain, and refined our senses. But then the mind staged a coup, according to Engels. And he says that the brain assumed control over the hand and its labor, and therefore the body ceased to be a collective and became under the control of the mind. So under this new hegemonic system, the body became full of gross inequalities in which the mind claimed all that the body produced. Basically, Engels' history of the hand is a prehistoric analogy of what he views as the rise and fall of the working man. According to Engels, the hand represents the worker, or the proletariat, while the mind represents the wealthy intellectuals, or the bourgeoisie. Engels' argument is that the mind-brain took power over the hand and created the current system of social inequalities which now define our world. So we have this unequal system in which the brain is in control of the hand and its products in the same way that the bourgeoisie, or you can think about the upper class, being in control of the labor and the products of that labor produced by the working class. All in all, Engels' basic critique of Darwin is that he focuses way too much on the brain and therefore ignores the role of labor in the development of mankind.